When you roll a die, you know every possible outcome, a 1, a 2, or a 6. But you cannot predict which specific number will land face up. That is the nature of a random experiment. On an exam, this unpredictability can make probability questions feel like guesswork. You can navigate that uncertainty using the probability flowchart. It is a logical system designed to help you calculate the exact likelihood of any outcome. By the end of this video, you will have a written template that converts a random event into a clear, repeatable calculation. Start by setting up your paper. Create a 2-column workspace to separate the physical steps of the experiment from the mathematical concepts we are tracking. Following the flowchart on the right, our first step is to define the sample space. The sample space is the set of all possible outcomes. For a standard guy, that set includes the numbers 1 through 6. It is important to use curly brackets here. We need to distinguish the list of specific outcomes from the total number of outcomes. Once you have listed the set, count the items and record that value. We have exactly 6 total outcomes. Mapping the sample space allows us to account for every possibility. The random die roll is now a fixed set of data. Now we move to the next stage of the chart, identifying the event. This is the specific outcome we are looking for, in this case, rolling an even number. Look at your sample space and identify the favorable outcomes. These are the numbers that satisfy our event. For an even number, those are 2, 4, and 6. We extract these from the main list to create a subset. Write Step 2, Event, and list those specific outcomes in their own brackets. Count the items in this new set as well. We have 3 favorable outcomes. We have now separated the relevant data from the rest of the sample space, giving us the variables we need for our formula. Since we are predicting a result using math rather than physically rolling the die and recording the trials, we are calculating theoretical probability. To find the answer, we use the theoretical probability formula, the number of favorable outcomes divided by the total number of possible outcomes. Take the values from your notes and plug them in. Favorable outcomes go in the numerator, and total outcomes go in the denominator, resulting in 3 over 6. Finally, simplify the fraction. 3 over 6 reduces to 1/2. The process is complete. We have quantified the chance of this random event happening as a precise fraction. Before finishing, we should verify the result. It is easy to accidentally flip a fraction during an exam, but we can check our logic using Rule 1. This is the probability scale. Rule 1 states that the probability of any event must be a value between 0 and 1. 0 means the event is impossible, while 1 means it is certain. Our fraction of 1/2 is 0.5. This lands exactly in the middle of the scale, indicating an even chance. Plotting your answer helps catch errors. If you had recorded a result of 2, it would fall off the scale entirely, showing you that the calculation is mathematically impossible. Because our result lands within the valid range of the scale, we can be confident in the calculation. This is the completed layout. By following the flowchart, we have turned a question about chance into a structured 4-step proof. This same 4-step architecture applies to any grade 9 probability problem, whether you are tossing a coin or drawing a card from a deck. Try using this template for a different scenario to see how the steps remain the same. Calculate the theoretical probability of drawing one specific card from a standard 52-card deck. Map out the sample space, identify your event, and share your simplified fraction in the comments.